Here's something that might shock you. Every infrastructure as code tool you're using today will be dead in upcoming years. Terraform, Pulumi, all of them. And the killer? AI agents that don't need the abstractions we've built our entire industry around. Now, I know this sounds crazy. You're probably thinking, hey, but we just invested years learning those tools. Here's the thing though, AI agents don't operate like humans. They don't get overwhelmed by complexity in the same way we do. They don't need user-friendly abstractions. And that changes everything. By the end of this video, you will see exactly why the tools we consider essential today are actually obstacles for AI agents and what's coming to replace them. But first, let me show you how we got here, where we are. Long time ago, providers of services realized that the only reasonable way for us to interact with what they offer is through HTTP APIs. Since then, everyone, and I repeat, everyone offers services through APIs. That can be AWS, Azure, Google Cloud, UpCloud, Linode, or anyone else, or anything else. We can get anything we need through API of the provider. Even if we do not use public platforms, but we do everything ourselves in our own on-prem data centers, everything is still available through an API. How do we get a new VM managed by vSphere? API. How do we deploy our application to a Kubernetes cluster? API. If you happen to work in a company where there are no APIs to manage whatever you're managing, I have an important advice for you. Run. Turn around, get out of the office you're in, and never look back. Go somewhere else. But here's where it gets interesting, and this is key to understanding why everything is about to change. It does not matter whether we interact with them directly, or through a graphical user interface, or through a terminal CLI, or through GitOps. It's always API. And the question is only whether we interact with it directly or indirectly. So the flow is human, that's you, request something directly by interacting with the provider's API, or to be more precise, with something as simple as CURL. Almost no one is doing that. Nobody interacts with AWS or Kubernetes or anything else with CURL. As a matter of fact, CURL might be the most efficient way to interact with API, yet we do not want to use it. Why? This is where the story gets really interesting. Why don't we do something like this? Or something like this? First of all, those are very simple examples. If you would like to create or update something, we would need to add JSON payload to those requests, and that would be a nightmare. Still, even in such simple examples, one can see how something like this, kubectl get namespaces, is much easier. So, to get back to the question why we don't do that, the answer is simple, and it reveals something crucial about the coming AI revolution. There are formats and tools that make it much easier to define what we want than to communicate with the API of the provider we're using. That's where Terraform, Pulumi, and others jump in. But here's what nobody talks about. Those tools were designed for human limitations. Terraform and other tools, often called infrastructure as code, have a very simple primary function. They help us define what we want in a user-friendly way. Their primary function is to transform HCL or YAML or some other format into API requests very similar to what we would do with CURL. That's what they do. So we change the flow by adding something like HCL in between us and sending requests to APIs. We write HCL or YAML or whatever we feel comfortable with, and those tools like Terraform and Pulumi translate that into API requests similar to what we would do with CURL and send them to API. Now, I know that those tools do more than what I described, but that's still their primary or main purpose. They provide a user-friendly way for us to define what we want and translate that into API requests. But here's the key insight. User-friendly means designed for human cognitive limitations. We get overwhelmed by complex JSON payloads. We make mistakes with intricate API calls. We need abstractions that reduce mental load. We require readable formats that we can understand, debug, and maintain. Those tools exist because humans are bad at complexity. We need simplification. We need cognitive shortcuts. We need tools that make something complex simple. And then we evolved further by coming up with state management. But wait, this is where things get really interesting. Kubernetes still does the same basic operations as what we were doing before adopting it. We define what we need, this time in YAML, and we use kubectl as intermediary that will communicate to the API. What makes Kubernetes different is continuous drift detection and reconciliation. And this is where we start to see AI-like behavior. Instead of performing operations right away, Kubernetes stores the desired state in etcd and lets controllers figure out what to do and when to do it. And on top of that, it does all that continuously. Those controllers are running in a loop and ensuring that the actual state is the same as the desired state forever and ever. If we specified that we want 3 pods and one of them fails, it will create a new one. If we specify that we want to scale nodes of the cluster whenever the usage reaches, let's say 80%, it will create new nodes, and so on and so forth. The major difference between the era before Kubernetes and where we are now is that operators inside the cluster, the controllers, took over a big part of the work we humans are doing. But we went further than that though. And this is where it gets crazy. Now our Kubernetes clusters are interacting with APIs outside the cluster. Once something reaches Kubernetes API, controllers might be transforming our requests into requests sent to provider APIs, be it AWS or Azure or Google Cloud or anything else. And that is awesome, since we can leverage Kubernetes controllers to do a much wider range of operations we had to do ourselves in the past. They can monitor the state of a database in Azure and fix issues caused by drifts between the desired and the actual state. They can manage Lambda functions in AWS. They can be in charge of a fleet of clusters in Google. Kubernetes controllers or operators are doing the work we had to do in the past. And here's the breakthrough insight. That's where we can see similarities between Kubernetes controllers and AI agents. Okay, so here's what nobody talks about. And this is crucial to understanding what's coming next. Every single generation of infrastructure tools had died when the industry shifted. And the pattern is always the same. Remember Chef, Puppet, and Ansible? Those tools were kings of the on-premises world. They managed server configurations, deployed applications, and automated infrastructure tasks. Everyone used them. They were the right way to manage infrastructure. Then the cloud happened. Suddenly, we weren't managing static servers anymore. We were spinning up and tearing down infrastructure dynamically. We needed to create databases, load balancers, and networks on demand. Did Chef adapt? Did Puppet pivot? Did Ansible transform into cloud-native tools? No. They tried. They added cloud modules and plugins, but they were fundamentally designed for a different world. They were built for persistent servers, not ephemeral infrastructure. They failed to make the transition. Enter Terraform, Pulumi, and CloudFormation. Those tools were born for the cloud. They understand immutable infrastructure. They could create and destroy resources. They were the new kings. New kings! But then Kubernetes happened. Suddenly, we weren't just managing cloud resources, we were managing resources through Kubernetes. We wanted everything to be a CRD. We wanted controllers to manage state. We wanted GitOps workflows. Are Terraform and Pulumi adapting? Are they becoming Kubernetes native? They're trying, but they're struggling. Terraform has Kubernetes providers, but they are clunky. Pulumi has Kubernetes support, but it feels forced. Those tools were designed for direct API calls, not for controller-driven reconciliation. And now we have Crossplane, Argo CD, Flux, and custom controllers. Those tools understand Kubernetes. They work through CRDs and controllers. They embrace continuous reconciliation. But guess what's coming next? I mean, you know it. It's AI agents. And here's the pattern. Every generation fails to adapt to the next thing, whatever is coming. Why? Because they're fundamentally designed for the previous world, for the previous way of working. They cannot just add features. They need to be completely reimagined. The tools that dominated one era became obstacles in the next. And the vendors? Well, they cannot let go. They keep trying to force their existing tools into new way of working instead of accepting that their tools have become obsolete. Now, this isn't speculation. This is history repeating itself. and it's about to happen again. But who knows? Maybe it doesn't have to. Here's what I hope will be different this time. I hope that Kubernetes native tool vendors will learn from history. I hope they will look at what happened to Chef, Puppet, and Ansible when the cloud arrived, and I hope that they will see how Terraform and Pulumi are struggling to adapt to Kubernetes. And I hope that they will make a different choice. Instead of trying to force AI agents to use YAML manifests and CRDs, maybe they will ask, hey, what do AI agents actually need? Instead of building AI assistants that help humans write Kubernetes configs, maybe they will build agent-native interfaces? Maybe Crossplane will evolve beyond compositions. Maybe Argo CD will transform beyond GitOps. Maybe the Kubernetes ecosystem will embrace AI agents instead of fighting them. But that requires something that is historically rare. The willingness to abandon what made you successful. The courage to kill your own products before someone else does. The vision to see that adaptation sometimes means complete transformation. Will they do it? Well, history says no. But I hope that this time will be different. I hope that Kubernetes generation will be the first to successfully evolve instead of dying. Time will tell. Now we're at the beginning of the AI era. Instead of writing that YAML ourselves, we can tell AI agents to do it for us. We are using AI to help us write stuff that we were writing ourselves in the past. That stuff can be YAML or HCL or backend code in Go or front-end application in TypeScript or anything else. From there on, the process is still the same. In case of resource management, that could be Kubernetes. That over there is, on the first look, very similar to what we do with Kubernetes controllers. If we define AI agents as processes that perform operations on our behalf, we can easily come to the conclusion that Kubernetes controllers fit that same description. In both cases, we define what we want, and they do it. An AI agent might write code based on our input. It might analyze a problem inside one of the clusters and suggest a fix or fix it directly. Similarly, Kubernetes controllers also take our input, the desired state, and make it happen. They ensure that whatever we specified is what is running. But here's where everything changes. Kubernetes is declarative and explicit. It will create and manage exactly what we tell it we want. We need to be precise. Or to be more specific, the desired state we define needs to be precise. We cannot instruct Kubernetes to run an application. We need to define a deployment, and inside that definition, we need to specify which specific container image it should use, how many replicas it should manage, and we can do many other things, and we have to do many other things. We can specify ranges though. We can say, hey, run between 3 and 7 replicas depending on the memory consumption. But that's still more or less very, very specific. AI is not like that, at least not today. It is not specific. It is non-deterministic. If we say generate application manifests and make sure that image is used and that number of replicas it will have, it will do that for us. However, multiple executions of the same prompt will produce different results. It is non-deterministic. Do you know of other examples of non-deterministic behavior? Well, it's us, humans. We are also non-deterministic. 2 people tasked to perform the same operation will end up producing different results. Heck, the same person is unlikely to produce the same outcomes when tasked to do the same thing twice. That non-deterministic nature of both AI and humans is important, and we'll get back to it later because it's about to become AI's greatest strength, most likely. For now, the important note is that the usage of AI through agents today is mostly limited on us instructing them to give us some information or to generate something. We use them to generate code or to write YAML manifests or something similar. Even when we do let them perform operations, we do that only in supervised mode. Agents suggest what they will do, we review those suggestions, and we allow or deny them to do whatever they wanted to do. All in all, today, we use AI to generate stuff we would normally generate ourselves. We trust Kubernetes to perform unsupervised operations because those operations are deterministic. We do not trust AI agents to do the same. And that will change very soon. And when it does, everything we built becomes obsolete. The problem is that we see AI agents as complementary to humans, and that's about to be our biggest mistake. A developer will use an agent to write code. Most of the time, at least when serious development is concerned, that developer will supervise the agent. It will tell it when it did something wrong. It will lead it when it goes astray. Similarly, someone called DevOps engineer, which is a silly name to begin with, or simply ops, or a platform engineer or something similar, will instruct the agent to generate some other code, including YAML or HCL. Today, we might go as far as to use agents to tell us what's wrong with the live system, and maybe even to suggest a fix, but not to fix it. Today, agents are supervised by people in specific roles. In our industry, those people are software engineers. And here it goes. Soon, the supervision part will be mostly gone. We will instruct agents to do something, and they will do it. We'll ask an agent to fix an issue in code, and it will fix it. And it will create a pull request, and it will review it, and it will merge it to the main branch, and it will deploy to production. Similarly, we might ask an agent to create and manage a database, or a cluster, or some other types of resources. That day is not today, but it will come. It will come very soon. Hence, the future flow will be from a human asking the agent to do something, and that agent doing whatever needs to be done. So, how will it do what needs to be done? The answer to that question is the same as how we were doing it so far. If we use APIs of the providers, be it Kubernetes or AWS or Azure or Google Cloud or vSphere or anything else. So, what is missing for that to happen? What is missing that will make agents autonomous? Now, to be clear, there are a lot of things missing, but I'll focus on two which I believe are the most important. First, agents need to develop capability to learn. Just as we humans are learning, bad things will happen. There will be suboptimal or even disastrous outcomes with agents, just as there are similar outcomes with humans. Making a mistake is normal. Repeating the same mistake is stupid. We're on the brink of having learning agents or learning models that will learn from mistakes, and by doing so, stop repeating them. The second important piece of the puzzle is that it is missing memory. We already have solutions for agents to memorize roles and processes and whatever else needs to be memorized, but those are far from being reliable. We need to get better at that. A new hire will spend considerable time learning how the company operates, whether to work in separate branches or push directly to mainline, which languages and frameworks are used in applications, which tools are used to manage resources, and so on and so forth. Similarly, all that internal knowledge needs to be passed to agents or models so that they can operate under the same rules. Actually, that over there is wrong. They should not operate under the same rules. We'll get to that later. What matters is that there must be rules followed by everyone, no matter whether we are talking about humans or AI agents. I have no doubt that we'll get those and other improvements we need. That's not my concern, at least not in this video. My big doubt is about tooling and formats and languages. And this is where everything breaks. Let's say that we want to instruct an agent to create a database. How would we do that? Natural reaction would be to instruct the agent to use the tools we are using, right? If, for example, we use Terraform, we would probably instruct the agent to create HCL files and then run Terraform apply, right? I think that's wrong. I think we'll have a major shift in that area, mainly because we're trying to force AI to use tools designed to help us, humans. Let's go back to that database example and think of the simplest way an AI agent would create it and manage it. Here's the breakthrough insight. We know that there is an API on the other end, and we know that Terraform, Pulumi, Crossplane compositions, and other tools and formats are converting user-friendly formats to API requests. Does the AI need those same formats? Can't it go directly to the API and make requests? What makes direct HTTP requests with JSON or some other payload any worse for agents than Terraform and other intermediary formats? You remember what we established earlier? Our tools exist because humans are bad at complexity. We need cognitive shortcuts. We need readable formats. We need mental models that we can understand. AI agents don't have those limitations. They don't get overwhelmed by complex JSON. They don't make syntax errors in API calls. They don't need user-friendly abstractions. They can handle raw complexity without breaking down. Or at least we think that they will be able to do it in not so distant future. We are used to abstractions because abstractions make our lives easier. AI probably does not need abstractions. As a matter of fact, abstractions will likely constrain it just as they constrain us. The major difference is that we get overwhelmed without abstractions. AI probably doesn't, or to be more precise, will not in the future. That being said, I'm sure that agents will need tools and specific formats, but those will be very different. Instead of trying to force them to use tools that help us, we should think of the tools that help those agents. What I'm trying to say is that agents will not need Terraform or Pulumi or Crossplane compositions. They can talk directly to APIs and do what needs to be done. They can observe the state of what was done and react when the state changes. They are, or they will be, acting in the same way humans are acting, but they are not humans. So they do not need the same tools, nor the same languages, nor the same formats. Now, you might say that's bullshit. Those APIs are too complex. They might not be well documented. They might not be the right interface for models and agents. You might be right, but if you are, the answer is still not Terraform or other tools, but as I already mentioned, tools designed specifically for agents. A good example is MCP or Model Context Protocol. If you need something from AWS and for whatever reason direct communication to its API is not a good option, agents can hook into AWS MCP and do whatever needs to be done. Terraform is not the answer. It is a tool designed for us, not for agents, and we should not try to fit it where it does not belong. Even if MCPs are not the answer, as I'm not sure that they are, there will be something else. And that's where the historical pattern becomes unavoidable. Just like Chef couldn't adapt to the cloud, just like Terraform is struggling to adapt to Kubernetes, Kubernetes tools will not adapt to AI models and agents. Why? Because Kubernetes controllers are designed for human-defined desired state. They expect explicit YAML manifests. They work with static configurations, but AI agents will work dynamically. They will make real-time decisions. They will adapt and learn and change their approach based on context. Will Crossplane adapt? Will Argo CD evolve? Will custom controllers transform? History says no. The pattern is clear. The tools that dominate one era become obstacles in the next. And we are about to see it happen again. All that means that many of the tools we are using will eventually stop being useful. There is no logical need for Terraform or similar tools for operations performed by agents. Those will disappear, or they will be transformed into something very different. They will die a slow and agonizing death. And they will make everyone using them suffer. Instead of thinking, how can AI do what we do using the same tools we find useful, we should focus on making tools that are useful to agents. Why would they write, let's say, HCL that is transformed to HTTP requests with JSON payload instead of making those same requests directly? Why would they use Crossplane compositions designed to make cognitive loads smaller for humans? We need to start thinking how we can enable those agents to do the right thing. We've been doing that with people for centuries, and now is the time to rethink everything. I do not yet know what will be that final form. I do not have a clear idea how will those tools look like, nor which formats will be most optimal for agents to do what they need to do. What I do know is that it will be very, very different than what we use today. That means that tools like Terraform, Pulumi, and others will disappear or transform themselves into something very, very different. The problem is that vendors behind those tools will likely not be able to let go. Most of them will not admit to themselves that what worked in the past will not work in the future. They will not recognize that agents do not need them. Instead, most of them will keep pushing the ideas they have today. Those ideas can be summarized with, we create agents that help us write stuff that humans are writing. If I'm HashiCorp, I'm probably creating agents and models that help people write HCL and execute Terraform apply instead of trying to figure out how to enable agents to do what they need to do in the most efficient and reliable way. As such, most of the tools from the established vendors will eventually disappear and be replaced by those built from scratch to meet the new demand. Just as Chef couldn't transition from on-prem to cloud, just as Terraform is struggling to transition from cloud to Kubernetes, those available today will likely not be able to transform into the world operated by agents. Most of them won't. Most of them will not be needed and will slowly die. 5 or 10 years from now, we will look at them with sentimental feelings similar to those we have for mainframe today. It's still in use somewhere, but most of us do not care for it. AI will kill most of infrastructure as code tools. It's only a matter of time unless they choose to evolve. The tools that survive the AI revolution won't be the ones that try to make AI fit their existing paradigms. They'll be the ones that completely reimagine themselves for the AI first world. They will ask the hard questions like, what if we abandoned YAML entirely? What if we built agent-native APIs from scratch? What if we killed our current products to build something radically different? The companies that make this transition won't just survive, they will dominate the next era. But it requires something most vendors struggle with: the courage to destroy what made them successful so that they can build things that will make them essential. History shows us the patterns, but history doesn't have to repeat if we choose to learn from it. The choice is theirs and the clock is ticking. Thank you for watching. See you in the next one. Cheers.